Okay, our last problem is going to be 33. A small sphere with mass 4 times 10 to the negative 6 kilograms. Mass equals 4 times 10 to the minus 6 kilograms. And charge 5 times 10 to the negative 8 coulombs. So Q equals 5 times 10 to the negative 8 coulombs. Hangs from a thread near a very large charged insulating sheet. So we got a sheet. We have our thread. Whoop. Here's our dude. And there's some angle theta. The charge density on the surface of the sheet is uniform and equal to negative 2.5 times 10 to the negative 9 coulombs per meters squared. Find the angle of the thread. Okay, so this is going to be an exercise in Newton's laws that we know and love. So we have the sheet. We know he's got some charge density that's negative. So our electric field is going to be pointing inward towards our sheet. Right? So, like we showed in number 26, the electric field due to an infinite sheet is sigma over 2 epsilon 0. And it does not matter how far away you are from the infinite sheet, because an infinite sheet looks like an infinite sheet whether you're right next to it or whether you're 100 miles away from it. Still an infinite sheet. It's huge. And the further away you get, the more of it you can see, so the more of it you feel, so it balances out. Constant electric field at all the distance. Distance doesn't matter. Alright, anyways. Alright, so that's the electric field set up by this dude. So let's draw a free body diagram for our charge. So we got our little guy. Boop, 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 boop. He's there. He's got some gravity pulling him down, like gravity does, because it's sad. This is a positive charge in an electric field that's going this way, and also you can tell just by how it's being pulled. It's going to feel its electric force this way. So this is going to be my F equals QE. And then I got some tension pulling me this way at some angle here. So we can bust this up into X and Y components like we usually do. So if we look in our X direction, the sum of our forces, we've got a tension sine theta, T sine theta, to get me this component, minus QE, and he's just chilling, he's not accelerating, so that's equal to 0. And in the Y direction, we have a tension cosine theta minus mg is equal to 0 because he's not moving, he's just chilling. Alright, so now we can use our handy dandy solving the system of equations. So I'm lazy, I'm a big fan of this way, dividing them, but we're going to write them out first. Alright, so we have T sine theta, move our QE to the other side, is equal to QE. And we have our T cos theta, move our mg to the other side, is equal to mg. Divide them, which is totally a legit thing to do, because this side is equal to that side, and that side is equal to that side. So this over this is the same as this over this. Alright, so my tensions cancel out. Sweet, because I didn't want to solve for that anyway. This is the lazy way to solve equations. Sine over cosine is tangent of theta is equal to QE over mg. And if you don't believe me that this is totally legit, you are welcome to solve for t and stuff it into the other equation and work it out that way. Alright, so we're looking for the angle. So to get rid of a tangent, we take the inverse tangent of both sides. So tan to the minus 1. So the inverse tangent of a tangent is just my angle. Theta is equal to the inverse tangent of QE over mg. So that's going to be inverse tangent of Q, which was 5 times 10 to the minus 8 coulombs. E was sigma over 2 E naught. I guess we'll just plug that in first before we stuff in numbers, because otherwise this is going to get ugly. All right, so Q, E is sigma over 2 epsilon naught over mg. Okay, so inverse tangent of 5 times 10 to the minus 8 coulombs times sigma was minus 2.5 times 10 to the minus 9 coulombs per meter squared. I already took into account the direction of my field when I was doing my Newton's laws, so I am not putting my minus sign in here because I already took into account the direction, and that is the only purpose of the minus sign. Over 2 epsilon naught is 8.85 times 10 to the minus 12 coulombs per Newton meter squared. Mass is 4 times 10 to the minus 6 kilograms. And G is 9.81 meters per second squared. I was about to say times 10 to the, but because I've been like used to doing things, powers. So I'm going to use this handy dandy calculator I found in Curtis 250A. If you know who this is, tell them I have their calculator. They can come get it in disc 707. I found it. Shame, shame. All right. So let's see if I figure out how to use this thing. 5 times 10. Oh my god. I haven't used a scientific calculator in like 10 years. So this is going to be a little embarrassing. Times 10 to the minus 9. Okay. Equals. Divided by parentheses. 2 times 8.85 times 10 to the minus 12 times 4 times 10 to the minus 6 times 9.81. Kablow. So then I want to do inverse tangent of the stuff. Blah. I hope this is in degrees. Yeah, it's in degrees. Okay. So theta is equal to 10.2 degrees. Ta-da! Yeah, we did it. Good job, team. That wasn't that bad, right?